Assalamualaikum and hello. In this video, we are going to learn about how to do a bit more calculation for the part of formation of line spectrum. In the previous video, you've learned how to draw and you learn also how to describe the formation of line spectrum based on this diagram. So this is energy level diagram for Lyman series. However, what I'm going to teach you in this video is how to calculate the difference of energy between two energy levels here. For example, if I want you to calculate the energy difference from n equals to 2 to n equals to 1, how you want to do the calculation. So, I'm going to introduce to you one formula so that you can use to calculate the energy difference, delta E. So this is the formula for energy difference, delta E, that we can use to calculate based on specific transition. What you need here is when I have EF, this is higher energy level, EI is for lower energy level, and I'm going to put the formula based on a specific energy level for that electron based on their initial and final, or based on their higher energy level or lower energy level. And you have this formula that you've learned so far. I'm going to insert this into delta E here, so you will have this formation of formula. Thus, I'm going to simplify this formula into the new form. For RH here is for Rydberg constant, and the value should be used is 2.18 exponent negative 18 joule. Next, once you put all the values into this formula, you will have the specific units for delta E. Your energy difference is in joule. Let's try example 11, where I need you to calculate the energy required when n electron move from n equals to 2 to n equals to 5. The important part for this question, you have to know which one is going to be your n initial, which one is going to be your n final. So I'm going to determine based on this question, the energy required is delta E in positive sign. Why? Because this word means the energy is absorbed. So that's why the sign for delta E is positive. After that, I'm going to label and choose which one is going to be my n initial and which one is going to be my n final. N initial is n equals to 2 because the word from, and then n final is going to be n equals to 5, the word to. So you have the information, you got this formula. I'm going to calculate the delta E here. So put the constant value, and this is going to be your final answer with positive sign as the symbol to indicate the energy required. Let's try another example. Now I want you to calculate the energy release when an electron drops from n equals to 7 to form a line in Paschen series. So this is where you are going to take out the information. The energy release is indicating that the delta E should be in negative sign. After that, you can determine that the statement from n equals to 7, automatically this is going to be your n initial. To form a line in Paschen series, so what is your n final? I've taught you before, for Paschen series, the ground state should always be n equals to 3. So that's why n final is 3. Now we got enough information to put into this formula. Insert the value correctly. You will have negative 1.9773 exponent negative 19 joule. Please remember, put the units for the energy difference, which will be in joules. Next, let's recall about the photon of energy. We know this photon of energy is the amount of energy released by the electron. So this is where the emission of photon release. So you have a specific value that you can calculate based on this amount of energy, where I have this formula, delta E equals to HV. So H here is the Planck's constant with the specific value that you've learned so far in unit joule second, and V here is the frequency. Once I know that the photon of energy is emitted in the form of light, I can also relate the formula for frequency with the speed of light, c here. And the value for that is 3.0 exponent 8 meter per second. Now we are going to get the new formula, delta E, which will be equals to hc over lambda. So in this part, you can understand that Planck's constant can relate with the energy, speed of light, and wavelength. Now let's try one example where I want you to calculate the energy change that occurs when electron falls from n equals to 5 to n equals to 3 energy level in a hydrogen atom. You have to determine the frequency and wavelength in nanometer of the radiation emitted. So let's take out a few information to do for this solution. You have here is the statement electron falls. So that's why the energy will be released. Your delta E should be in negative sign. Next, you have the statement from n equals to 5, this is your n initial, to n equals to 3, this is your n final. Then, we can use this formula to calculate the delta E. So you put the values correctly, you will have delta E is negative 1.55 exponent negative 19 joule. Next, you got the energy change. It asks you to determine the frequency and wavelength as well. So I'm going to use another formula, delta E equals to HV. What I have here is just put the value that you got for the energy, and in this part, please take the value only during the calculation. You don't have to bring the negative sign here for the energy difference, because the negative sign is just to indicate the energy release. So I'm going to rearrange my formula with the correct value. I will have my frequency is 2.34 exponent 14 per second. This is the unit for the frequency. And next, it asks you to calculate the wavelength as well, but in specific unit, nanometer. So I'm going to continue in the next slide for the wavelength, where you got all the information just now. I'm going to determine the wavelength, which will be frequency equals to speed of light over lambda. So the value for lambda is what I'm looking for. So I put the value that I have for frequency and speed of light. You will have lambda is 1.283 exponent negative 6 meter. This is because you cancel out the unit per second, you left with meter. However, the question asks you for the wavelength in nanometer. So in this case, you have to convert into nanometer, which will be 1283 nanometer. So I hope you understand how to calculate the energy difference based on several formulas that I've introduced to you. That's it for this video. I'll see you in the next one. Bye!